Okay, it looks like we're live on Facebook now. Welcome everybody to the first Sherpa webinar of 2022. We're hoping to make this a regular thing. We're going to have some past paper breakdowns every other week, every couple of weeks. And we're kicking it off today with the 2017 Pearson Edexcel paper 1. I'll let Tim talk a bit more about it. But yeah, this is presented by Sherpa Online. If you haven't heard of Sherpa, give them a Google. It's one-to-one qualified teachers or one-to-one tuition from qualified UK teachers. So head over to the website, have a look. You can even have your own private sessions with Tim, which I'm sure he would definitely encourage. And you'll be able to find all the links in the comment section below. We do realize this is quite early. So, you know, fear not if you can't watch all of it. What will happen is we'll be doing a YouTube premiere at 4:30 today, where the entirety of this recording is going to be put up on our YouTube channel, and you can watch along in real time. And then what will happen is the paper will be broken down into different sections and different questions. So it may be, you don't need question 1, for example, but you might need question 16. You can go onto our YouTube channel and it will all be there. Okay, that's pretty much everything from me. So whether you're watching live or you're going to be watching the premiere at 4:30 or even into the future, good morning, good afternoon, good evening, and over to you, Tim.
Great, thank you very much, James. So yeah, I'm going to go through this foundation paper. So this will take you up to a grade 5. And that actually what we do, we often encourage some of the higher level students to have a crack at this paper as well. If you look at the second half of this paper, it will be sort of grade 4, grade 5, even some grade 6 stuff. So there's something in it for everybody, this paper. If you are a higher level candidate, I would just encourage you to go to the last third of the paper and just have a look at that. Now I'm going to try and do this 1.5 hour paper in about 50 minutes. So what I'm going to do, I'm going to pause at certain times. And if you need time to do the question yourself, your end, that's what you can do. So just feel free to pause, to rewind, to go over things again. And some questions, I will just show you a solution without a long commentary. Okay, so it's worth 80 marks. And once you get to about 75%, that's about 65 marks, then that would get you the grade 5 you want. Okay, and it always starts off with some fairly straightforward questions. Let me just zoom in here. We've got question 1, work out the value of 2 to the power 4. Well, 2 to the power 4, as you know, is 2 times 2 times 2 times 2. So 4 times 4 is 16 there. Question 2. It asks us to write this number 7.24451 to 3 decimal places. So what we'd do there is we'd argue that the 3 decimal places end right there. And you can see that the number after that orange line is 5. So the 4 rounds up, giving us 7.625. Okay, before I go on much further, if you want to get a blank copy of this paper, they're all freely available. There's a couple of sites which encourage you to download these papers. There's one called Maths Made Easy, and again, it just takes a few clicks to get the papers. And there's also Physics and Maths Tutor, and they have a whole heap of good stuff, which are just completely free. So you can download the blank paper and do it in your own time, and then look at this recording to go through things. Okay, and number 3, we're asked to simplify that the 2 digits are 7 and 8. So 7 8s are 56. And we just get rid of the time signs there to simplify it. So pretty easy there. Next question is, I'll just show you this. I'll just blank that out. What we're asked to do is we're asked to do x over 5 times 2.5. So what you can do there is multiply both sides by 5 of that equation. Okay, and if you do that, we get x is 5 times 2.5. You could do that in your head, 12.5, or if you're not sure, you can do the normal thing. We've done it here actually. it's 5 over 2 times 5. 5 5s are 25. 25 divided by 2 is 12.5. There we go. Okay, number 4, quite straightforward. Right, 4/5 as a percentage. You probably know that 1/5 is 20%. Okay, if you don't, just imagine you've got some friends, you've got £1, you're squabbling over it. There are 5 of you, okay, and you can see, I hope, that if you divide £5, maybe £100, well, £1 divided by 5 is actually 0.2. So 1 over 5 is 0.2. You can put a 0 there if you want as well. Okay, so that's all good. And 4/5 is going to be 4 times 20, 80%. Okay, so we're aiming to get sort of almost 100% on some of these early questions. And things will get more and more difficult. You haven't got a calculator, so I'll try and show you some tricks as we go along here. Okay, working out 60% of 70. What we can do here is we can just argue that 60% is the same as 6/10. So we're really trying to find 6/10 of 70. And 6 times 70 over 10, we can also argue that's the same thing. And 6 7s are 42. You've seen here we've divided by 0 top and bottom. Okay, I'm going fairly fast here, guys, so please feel free just to, it won't be a problem for you. Don't feel it's no problem at all if you want to go back and look at things again, or even speed things up. Okay, here we've got a spinner, and we've got 2 Bs. It's a little bit of a trick question. You have to kind of spot that. So actually, the chance of getting 2 Bs is 2 out of 4. Excuse me. Which is 2/4. It's a half. So actually, the probability is 50% or a half. Okay, probabilities you can write as fractions, decimals, or even percentages. So 0.5. Excuse me, would also be appropriate. And then it says, what's the chance it's going to land on an F? Well, impossible. You can't get an F. So that's 0% probability. Okay, good. Let's just keep going on. So I'm just going to give you guys a time just to read through this question, because it's just a little bit wordy, this one. So I won't read it out off the page straight away. Okay, so this is Fahima, and she's buying 2 bread rolls for £1.50. So when you read this for a second time, you can start to make some notes. So 2 bread rolls at £1.50 is £3. There's the bottle of ketchup for £1.60. Okay, and now you don't have to use algebra, but if you do, it's quite an elegant way to do it. And the 3x, we don't know what 1 pack of sausages weighs or costs, so we can just say use x. You just write x like that, and the examiner will get that straight away. Okay, so if you add those up, you've got 3x plus 40, and then it said she gets 30p change from £10, so she's clearly spent £9.70. So this is a really nice way to do it, and again, this is a very mathematical sort of training you have to do this. Now, you don't have to do it this way, but really neat thing to do is to set up your little equation. 3 times the packet of sausages, 3 times the sausages, whatever that is, plus £4.60 equals £9.70. So we'll just treat that as an algebraic equation. And if you subtract £4.60 from both sides, you get £5.10. Divide that by 3. £1.70. So that's the way to do it. Now, you haven't got a calculator. Excuse me. So what you'd be doing there is if you couldn't see that in your head, you'd probably be using a bus stop. It's actually not the most easy one to do, even with a bus stop, but we've got 51. We'll call it 51. We're dividing by 3. Yeah, now that's a bit tricky because we've got 3 into 5 goes once with 2 left over, and then 3 into 21 goes 7. So it's 1.7 or £1.70. So yeah, so don't forget your bus stops. They do come up 2 or 3 times. It's absolutely amazing how many secondary school students they've forgotten how to do bus stops. They've forgotten how to do long multiplication. So that's something just to refresh. You will have been able to do it in the past, and you've forgotten how to do it quite possibly. Okay, let's just zoom out and give the answer there, £1.70. Okay, I'm going to go really quickly through question 8 because once you know what you're doing, it's really easy. Fractions, the easiest one is multiplication. They've kicked off with the most easy one. 5 times 3 over 8 times 4 is 15 over 32. That can't be simplified. The answer's 15 over 32. Okay, next up, we've got the 2/3 minus a quarter. So this is where we need the common denominator. Okay, so for adding and subtracting, you need the common denominator. So there's 3 on the bottom, 4 on the bottom. We're trying to get a number that causes those 2 numbers at the bottom to become the same. So what can we do? Let's times the first one by 4 and the second one by 3. So the first one, we times the bottom by 3, the top by, we times the denominator by 4 and the top by 4 as well. So we get 8 over 12. Next one, we multiply top and bottom by 3. We get 3 over 12. 8 over 12 minus 3 over 12 is 5 over 12. That's it. Okay. I'm going to give you guys a chance just to read this question before we actually do it. Now, if you're working on your own with this paper, what you can do is you can just read the paper, do the question, and just ignore all the writing underneath. So you don't have to read everything on all the working on the page there. You can just quietly get on with number 9 and then check out the solution, either at the very end when you finish the whole paper or as you go. So that's what we'd encourage you to do. I'll just give you a chance to read through the question. Yeah, okay. So overtime pay, that's where you get 1 1/4. That's 1.25, 125% if you like. So get 125% of your normal pay. Let's just work that out first of all. So 1.25 times 15 is 12 times 1.25 is 15 here. What you can do there is you can do 1/4 of 12, which is 3, and add it on to get 15. Okay, so he's working 8 hours at £12 an hour and 2 hours at this added extra rate, £30. So if we add that up, 8 12s are 96. 96 plus 30 is going to give us the £126. Okay, so that's okay. Let's see how many marks there are for that one there. Yeah, 4 marks. Okay, just a word about this question. A lot of high-level candidates would find this easy, but it's surprising how many high-level candidates lose marks on these. So if you need to, just slow down to do these questions. Okay, next up, we've got question 11. It's your classic pattern. Just give you a chance to read that all through. Okay, so we've got square tiles, we've got circular tiles, and the first thing to realize is that the pattern number relates to the number of squares in the center there. So choose squared. If you square the number, 1 squared gives you 1, 2 times 2 gives you 4, 3 times 3 gives you 9. So all you have to do with that pattern number 6 is square it, multiply it by itself, 36. And then what we're doing, we're kind of sort of examining the pattern here. How many circular tiles are needed to make pattern number 20? So what we're realizing here, we can just write down the information we've got so far. So pattern number 1 gives you, it was 4 tiles. Pattern number 2, yeah, when I say tiles, I mean the ones on the outside. Okay, pattern number 2 gives us 8, pattern number 3 gives us 12, etc. So you can see this pattern here, you just multiply that bottom number by 1 and you get the answer. So there it is. Yeah, so the answer is, if you've got 20, it's 80 there. Okay. And then it says, when the pattern number is odd, an odd number of square tiles is needed to make the pattern. Okay. This is a little bit tricky, actually. It's almost off the syllabus for GCSE, but what you can argue, if your pattern number is odd, what you're doing, for instance, is, we'll take a look at this third one. We've got pattern number 3. That gives us 3 times 3 is 9 tiles. So actually what you're doing is you're doing an odd number times an odd number. Now, this is a little bit tough, really, but there is this fact that an odd number times an odd number is always an odd number. So it doesn't matter what numbers you choose. If you're multiplying 2 odd numbers together, you get an odd number. Now, to be absolutely honest, that fact there isn't always taught in press textbooks. So there's a little bit of maths instinct there, but the answer is yes. Okay, good. Let's carry on. So we're going to look at number 12. If you've got a blank paper in front of you and you just want to do number 12, you could, of course, just pause the tape now, pause the video now, and you'd be ready to go. Okay, so here we go. I'll read this one out, actually. There are only 7 blue pens, 4 green pens, and 6 red pens in a box. The pen is taken at random from the box. It says, yeah, write down the probability that this pen is blue. Well, just write down the different combinations there, the different colours. 7 blue, 4 green, and 6 red. We've actually got 17 pens and 7 blue, so it's 7 out of 17 are blue. Okay, now that there would get you 2 marks straight away. If you want to convert that to a percentage, that's difficult without a calculator, because 17 is a prime number, but you can do that. You can also write it as a ratio if you really wanted to, but that wouldn't be advised. Okay, so 7 over 17 is just the best way to leave it. Okay, excellent. Okay, now question 13 is a bit strange. It's actually very easy, the maths, but people have had students recently sort of not quite knowing what's going on here. I'll just read it out. The diagram shows a tree and a man. The man is of average height, and the tree and the man are drawn to the same scale. Write down an estimate for the real height in meters of the man. Now, the key word there is estimate. Okay, you don't have to get a ruler and measure the length of that man in millimeters. Just work it out roughly. Okay, now for this question to work, there are some things that you're supposed to do at primary school and you're supposed to remember. So people forget loads and loads of stuff, so don't be embarrassed if you've forgotten this. But the textbook average height for a man is 1.8 meters. That's the height of a man. Of a lady, it's 1.6 meters. the average mass of a man is 80 kilograms and 60 kilograms for a lady. Now they are very, very approximate. They're also slightly outdated. We might be arguing people are a little bit bigger than they were 10 years ago when we had these figures. So what we're going to use here is the fact that that man is about 1.8 meters. And all you need to do here, we're asked to find an estimate for the height of the tree in meters. Well, all you have to do is realize that if you look at that green line there, it's actually about 6 times the height of that man. So whatever you take for the man, I'm going to do mine. I'll do it in orange. So I'm going to take 1.8 and I'm going to multiply that by 6. Now, because it's an estimate, you're even allowed to call that 2 times 6, which is 12. So you could argue the tree is 12 meters. I've gone a little bit over to the 1.8 to 2. So you could even say that the tree is approximately 10 meters high. Okay, I'll just show you what somebody else has done. So they've said a height anywhere between 1.5 and 2. They're calling that 1.75. They've multiplied by the 6. So we're kind of just assuming that that is 6 times the height of the man there. You could have gone times by 5. Anyway, whatever calculation you choose, anything between 7.5, I think it was, and 12 is allowable. On the mark scheme, apparently. Okay, so that's kind of easy marks once you know what you're doing. Okay, when you're ready, we'll look at the pie chart. Okay, I'm not going to show you the drawing of this, how to construct it. It's quite difficult doing that on screen quickly, but we'll certainly go through that any other time. Yeah, okay. So I'll just read out the question. We've got Year 9 students from Halle School. They're asked to choose one language to study. And here we go. French was 56, Spanish was 40, German was 24. And you've guessed it, it's a pie chart. Okay. So this method here, it's going to work for any pie chart information. Okay, so let's just have a look at that. We've got 120 students. I'll write this up in orange. We've got 120 students. And for those 120 students, we've got 360 degrees to kind of share out. Okay, so what you can do, you can just argue that for one student, you can kind of divide both those numbers by 120. And you get 360 over 120. You get 3 degrees. Okay, so 3 degrees for each. You can see what's happening. We can multiply all these angles, all these numbers of students by 3. Okay, and that will give you the answers 168, 120, and 72. Okay. Now, what's happened here is we haven't labelled this quite correctly, actually. So if you look at the mark scheme, they do want you to label it with words. So for the 168, that's the French people, French lovers. Spanish is the 120, so this is Spanish. Okay, and the 72 is the German. Okay. And what we're expected to do also is, if you look at some mark schemes, they want you to actually put the numbers down. So 56 students, 24 students, and Spanish is 40 students. Strictly speaking, right in the word students there. Okay, that there, you're allowed to be 1 millimeter out generally, or 1 degree out generally for the angles. Sometimes you get like a composite error effect, so they might allow a little bit more than 1 degree out. Okay, and have a fairly sharp pencil for this. Okay, let's move on. I might have to accelerate a bit just to make sure this is done in the time we've got available today. Always try and keep things to just less than an hour to fit in. Okay, I'm going to go straight to number 15 now. Okay, and I'll read this one out. Here are a triangle and a rectangle. The area of the rectangle is 6 times the area of the triangle. Work out the width of the rectangle. Okay, so we've got a triangle, we've got a rectangle. We're going to call that width W, and we're trying to find that width there, W. Okay, so what we can do, we can find the area of the triangle, half times the base times the height. So that's a formula to remember. Half times 8 times 9, half times 9 times 8. 8 9 is 72, half of it is 36. And the area of the rectangle is 16 along, and it's W, the width, so it's 16 length times width is, we'll just call it 16W. Okay, so here's the nice thing. We can just say that 16W is 6 times, in yellow there, the area of the triangle. Okay, and if you work that out, we can divide both sides by 6 to start off with. Sorry, multiply the right-hand side by 6. We get 16W equals 216. And then we can do 216 divided by 16. Okay, I'm just going to show you a little trick here, which isn't used enough by GCSE students, actually. So I'll just take that from where we've got it. So we've got W equals 216 over 16. Okay, so you can kind of do that in your head or on a bus stop, but it's much easier actually if you just sort of play around with it. If you halve the top and bottom, 108 over 8, halve it again, 54 over 4, halve it again, that is 27 over 2. And 27 divided by 2 is you can see that's 13.5. So yeah, that's what you can do there to speed things up. Okay, what I'm going to do now, I'm going to speed up on the easy questions. Okay, number 16, v equals u plus at. We've got to put the numbers in. U is 1, a is minus 3, t is a half. Just put the numbers in. Okay, it's 1 minus 3 times a half. Minus 3 times a half is minus 3 over 2. I'll just show you that on the side. Minus 3 times a half is minus 3 over 2, which is minus 1.5 if you want. So we've got 1 minus 3 over 2. You're probably going to call that 1 minus 3 over 2 is actually 1.5. So it's 1 minus 1.5, which is minus a half. Okay, let's keep going. Okay, we'll just have a quick view of how many questions there are to go. We're getting towards the halfway mark here. Yeah, so what I might do is I might just go through some of the questions really quickly, just give you a chance to see it, stop the tape and look at it in more detail. Okay. Okay, so I'm going to do a speed review for this question. We've got 5 tins of soup. We've got a total weight of 175 grams. 4 tins and 3 packets of soup. We've got a total weight of 1490 grams. Okay, so the first thing to do is to find the cost of 1 tin. Okay, and to do that, we've got 5 tins weighing 1,750 grams. Divided by 5, 350. Okay, again, if you want a bus stop for that, just check that. Okay, so 5 into 17 goes 3. and then there's 2 left over. 5 into 25 goes 5 times with a 0. Okay. So we know what wanting is. Now what we can then do, we can state this next statement using algebra. 4t plus 3s. S is the soup. And then we work that through. I'll just leave you to screenshot that one there. It's actually quite straightforward once you get going. Okay. Question number 18. Just give you a chance to read that question, then have a go at doing it. Yeah, so just to paraphrase, we've got this this circular garden with a radius of 10 meters, and we've got grass seed covering approximately 50 meters squared of the garden. There is that keyword estimate coming up, so call that 50 square meters. Okay, so work out an estimate for the number of boxes. Yeah, okay. So the estimate there, let's get that sorted. The estimate there, you need to know the area of a circle, which is pi r squared. You need to know that pi is approximately 3. Okay, so pi is approximately 3. So what we can do here, we can say the area of the circle is pi r squared, pi times 100. You can just leave it as 100 pi if you want, or you can leave it as 300. Not a problem there. Okay, so we've got the number of boxes we need is 100 pi divided by 46. They're here arguing that the value of pi is 3.1, so they're calling it 310 divided by 46. Do not get a bus stop out, just do this very, very roughly. In fact, personally, if I was doing this, I would just call that 300 divided by 50. The answer is approximately 6. Okay. So, yeah, the mark scheme there allows 6 to 8. Okay. I'm going to leave part B because it actually depends what you wrote for part A. So that's actually not a great question to go through at the moment. You might have done it different ways. Okay, so nice algebra now. So I'm going to do this pretty quickly. Multiply out the brackets, simplify, divide both sides by 4 in the end, you get x is 9.5. Okay, we've got t is greater than -1, less than or equal to 2. Possible values of t are just the whole numbers, greater than -3, as shown here, -2, -1, 0, 1, 2, etc. Okay. Just read this question out. Asmod is paid £1,500 per month. He's going to get a 3% increase in the amount of money he is paid. Work out the amount of money Amzell will be paid per month after this increase. Yeah, so what we can do here is, this is a crafty way of doing it actually. You can argue that 1% of 1,500 is £15. If you're not sure about that, let me just get my orange pen. Okay, 1,500. We're going to divide by 10. Take the decimal point to 150. We're going to divide by 10 times 10, 100. So we've got 15 there. So 1% is £15. 3% is £45. Add that on, you should get £1,545. Other methods exist. Okay, let's keep going with question number 20. Okay, I'm just going to make some points here. That point there is an outlier because it's not on the line of best fit. It's miles out, and you've got to write down the coordinates. The type of correlation is it's going up, so up is positive. There's positive correlation. As one number gets bigger, the other gets big. So up is positive correlation, down is negative correlation. Yeah, okay, so that's quite quick. Oh, and I would say, if you draw in your lines, your line of best fit, and draw in your lines to read off the numbers, that's part of your working. So if you go wrong, they'll still give you some marks, probably, if they can, if they're available for that. So loads of working is all really good. Okay, we're starting to get into the more tricky part of the paper. So we're looking at sort of grades 4s and 5s here now. I won't go through that graph question there. It's actually rather straightforward and a bit silly. So if you'll forgive me, I'm going to miss that one out. Okay, number 22, right? 56 is the product of its prime factors. Here we go. A beautiful factor tree. Remember factor trees? 2 into 56 goes 28 times. 2 into 28 goes 14 times. 2 into 14 goes 7 times. Out pop the prime factors. Okay, there are other ways you might have been taught that. So some people lay it out a bit differently. It amounts to exactly the same thing. 2 into 56 goes 28. 2 into 28 goes 14. 2 into 14 goes 7. And that's 7 into 7 goes once. And that's how far we've got. So 2, 2, 2, and 7. Okay. So most people write that as 2 cubed times 7. Good. Okay, let's keep going. Okay, now here we go with just a straightforward, rather unpleasant multiplication. Now there are so many different ways of doing this these days that I'm going to let you practice your own way. But we've got the Chinese method, which is actually not that well known, but is used successfully. We've got the grid method, so you break down 54.6 into 54 and 6, and you've got the 40 and the 3. That's absolutely fine. All these methods work fine. And then we've also got the traditional method, the long multiplication, which I've shown you here. Okay, now I won't stop and go through every single answer, but what you need to do here, guys, is the answer is 234.78. Just stop the video, make sure you can do that. If you can't, we've got kind of solutions for all the different methods you might use here. So you just want to pause the video there, check that out. Okay, right, nice question here, number 24, really nice question. So definitely this would be high level candidates would be all over this. Foundation students will find it a bit tricky actually, but here we go. We've got an area of a square. Yeah, it's ABCD. It's got an area of 10 square centimeters. And we've got to show that the area of that square is x squared plus 6x plus 1. Okay, so it's a really nice thing you can do here. You can just work out the different areas here. Now I'm going to do it a slightly different way to this person. So we've got a 3 times 3, that's a 9 area. We've got 3 times x, which is 3x. So we're looking at this length here being 3. Okay, down here, this length is 3. So that length is 3. This length is x. We're just looking at x's. Okay, 3 times x, x times 3 is 3x. X times x is x squared. Okay, so what you can do there is you can add up these numbers. Okay, that's a really nice thing to do. If you add them up, you get x squared, bottom right. You've got the 2 lots of 3x. And then top left, you've got the 9. And that area is 10, we're told. Okay, so x squared plus 6x plus 9 equals 10, that should say. I think you guys can see what's going to happen here. We're going to subtract 9 from both sides. X squared plus 6x equals 1. Job done. Okay. Oh, these guys have done it completely differently. Okay. I did this last year, so it's just, there are different ways of doing it. What they've done is they've multiplied x times 3 times x times 3. Sorry, x plus 3 times x plus 3. And they've done it that way, which is absolutely fine. In fact, they haven't used the diagram at all, really. Okay. Either of those methods will get you 4 marks. They've just expanded the bracket there. Okay, fantastic. Let's have a look at this next question. Okay, I'm just going to let you guys read that question there because it's a little bit fiddly. Yeah, so we've got a rectangular frame. It's got 5 straight pieces of metal. The lengths are 12 meters and 5 meters. We kind of need to find that length there, the diagonal. And we've got to find the total weight. So we need to find the length of all the different bits, and then we can multiply it by 1.5. But first up, Mr. Pythagoras, he would have had something to say about this. He would have said, aha, we can find that diagonal there using Pythagoras' theory. So you'll remember, hopefully, it's the short side squared, 12 squared, plus the other short side squared, 5 squared, equals the hypotenuse squared. I'm thinking my headset. Okay, forget the headset. I think it's not an issue. Yes. Actually wearing it. It's very funny. Yeah, where are my glasses? Where's my headset? It's on your head. Okay. Yeah, right, let's move on. So yeah, so if we work out the length of this diagonal, x squared is 169. Now that's a little bit mean. I think that's a bit harsh because basically, people should know all the different square numbers up to 12. Okay, etc. 3 squared is 9. Now, it's a bit mean. 12 squared, as you should all know, is 144. It turns out that 13 squared is 169. So you kind of need to have spotted that. Although, having said that, you could actually have just left the answer there as root 13. Sorry, root 69. You could have left that answer as root 169, and they would have allowed that. Okay. The only thing is we've got to find the total length. We've got to add these numbers up. We've got a 12 on the top and the bottom. We've got a 5 on the left and the right, and we've got this 13 that goes across, and that's 47. So that's the total length, and you need to show loads of working here. That's the total length. Yeah, multiply that by 1.5, and there we go. Okay, so probably just find a half of 47, 0.5, and add it on. I'll just do that in orange. So if you're trying to find a half of 47, you can use a bus stop. Most people will go 40 divided by 2 is 20, and 7 divided by 2 is 3.5, so add 3.5. Okay, so that's the kind of thing you need to be able to do, something like that. The answer is 17.5. Now they've done something a little bit naughty here. Okay, yeah. Oh, that's okay. They hadn't put the units in. So if you can, make a point of filling in the answer down the bottom right. You don't have to actually get the marks, but they might conceivably argue that if you leave that as the answer, they might take a mark off because you haven't put the units in. It does depend on the mark scheme. Physicists, people doing physics and chemistry, have probably told you have to give the units for everything, otherwise you can lose some marks. Okay, so we're entering the last part of the session now. We'll just see, I think we've got 4 questions left. No, these are the last 2, so we can relax a bit with these. Okay, I'll just give you guys a chance to read this question. Yeah, so we've got two lines. One line is y equals 3x minus 2, and the other is 3y minus 6 minus 3y minus 9x plus 5 is 0. Okay, so what you need to remember here is y equals mx plus c. Okay, m is the gradient. And c is the intercept. Yeah, and what then happens is we can look at this first line 1. We can see that the gradient there is 3. Now the problem we got with this second one, line 2, I'll highlight it in green there. That second equation, it's not in the form y equals mx plus c. They've messed us around. They've written it like that. So what you want to do here is you want to change it into the form y equals mx plus c. In fact, this person here, they've actually just divided everything by 3 first stop. So they've said that y is, divide the 3y by 3, you get y. Divide by 3, you get minus 3x. Divide by 3, you get 5 over 3. Okay. If you then move everything to the right, so I'll show that with an orange pen. So we're adding 3x to both sides, and then we're subtracting 5 over 3 from both sides. You can see the answer is that this second line can be written as y equals 3x minus 5 over 3. We're not interested in the 5 over 3. We're just interested in that 3 they've shown in yellow here. So the coefficient is the number before the x. So the 3x tells us that's the value of m is also 3. So that means these two lines are actually parallel. Okay. Yeah. Okay, and that's just 2 marks for this. Okay, question 27. Now this is a little bit of a tough question for foundation level students. Foundation students possibly haven't been shown vectors, but just to help you with this, we've got a parallelogram. The diagonals intersect at 0. Vector OA is A. So just think of A, that's called a vector, as a step, one step in that direction, parallel to that line OA. That is vector A. Now you could do something a bit of a longer step and in a different direction. Somebody else might take one step in the B direction, bit of a bigger step there. So that's all we're doing here. It says find in terms of B the vector DB. It's going from D to B. Actually, if you go from D to B, that's from there to there. Can you see that's one step in the B direction? In fact, there'd be another step in the B direction. In fact, I've written it here earlier on. So it's actually 2 steps in the B direction, which we just write as 2B. Okay. Strictly speaking, the A-level students will write a little squiggle underneath there. You don't have to do that. They can see a squiggle or a line, actually. If you do A-level, you'll come across this. But for GCSE, if you just write 2B, 4 marks, no problem. Okay, and lastly, find in terms of A and B the vector AB. Okay, now that's a little bit nasty. But what we can do, I'll just show you this with a highlighter. Let's get a neon highlighter. If you want to go from A to B, you can go this direction in the direction of A, and then you can go that direction in the direction of B. Okay, my highlighter works. Now the only thing is you're stepping in the opposite direction to A, so technically that's a minus A. So the answer is, if you want to go from A to B, you go one step in the opposite direction of A, and then a full step in the direction of... I've misread the question. Let me just go back there. Okay, so if you make a mistake, don't worry, you can still get full marks. We're going from A to D now, okay, which is there. So from A to D, we're going to go one step in the opposite direction of A and one step in the opposite direction of B. Just clear a space so I can see what's going on. Clear the whole thing. Okay. Yeah, so I'll just say that again. We're trying to go from A to D. And what you do is you go one step in the opposite direction of A and one step in the opposite direction of B. So that's minus A, minus B. Okay, and there are other ways of going through that. Right, guys, I think we've pretty much finished there. Now, I did rattle through that, that paper in about 50 minutes. Okay, so if you're wanting to watch this at home or use it effectively, a really good way to work is just to print off a blank copy, do as much as you can. Then you've got a choice. Either you can do the whole paper, mark it all in one go, or you can just do one question and then mark that question as you go. It's kind of up to you, whatever works best for you. You should be able to go back and forward along the recording, so you can sort of jump in where you want. If you're a high-level candidate, high-level candidates can just jump to they can just ignore all the questions in the first half, go straight to the end. Right, okay, I think we'll just go back to the top of the exam, and then I'll wish you all well. So yeah, so to get a grade 5, you need roughly 70% here. Now, if you want to find if you do this question, this paper, and you get a certain mark, you can go and look up the grade boundaries on the internet. You just type in GCSE Maths Foundation Level May 2017 exam grade boundaries, and you'll get very, very quickly, you can work out what grades you got from that paper. Okay, that's all from me. I think I'm going to stop sharing or let James take over now. Over to you, James.
Cheers, Tim. Well, I know I don't speak, or I do speak for quite a few of us here in the office, that we kind of went, wow, okay, that's a lot more complicated than we expected. But no, that was brilliant to just run through it and relearn some stuff. It's been a good few years since I had to take this paper. I think I took the 2016 one, actually, thinking about it. No, right, 2014. Yes. I took the 2014 one. So yeah. Seeing how it's changed 3 years later.
They just decided to make it a lot more difficult. So there's less easy questions. I think in previous years, this kind of paper would have been 70% really, really easy. But now there's very little that's very, very easy. So they've just made it tougher.
Yeah, it's definitely. I never used to see the interest in a TV show. Are you smarter than a 10-year-old? But now I'm starting to be convinced by it. So yeah, no, that was brilliant. So just for anyone watching the YouTube, if you head down to the comment section and just drop a comment, maybe ask a couple of questions, we'll be happy to answer them. I'll even put some of them towards Tim in an email, see if I can get a proper answer instead of just having a Google. And if you are actually looking for this paper or some other papers, they will all be in the description of the YouTube video as well as Tim's Sherpa profile. There'll be a direct link to that. The entire Sherpa Online website will also be in the description. So thank you for those of you watching live. I'll thank Tim again. And yeah, if you're watching the rerun, scroll back, make sure that you've got all of those questions down and all the working out, and go and impress your teachers in school. So yeah, I think we'll wrap it up there. Thanks again, Tim. Any last words?
No, thank you very much. I think we're starting again in a fortnight. It's a sort of fortnightly thing. So yeah, tell me if I can improve the lesson in any way. Go a bit faster. I tend not to worry about going too fast when I'm recording, because I'm aware people can go back and even slow things down. So yeah, I wouldn't always go that fast in a classroom full of 30, 15-year-olds. So I've really belted through that one there. So if you couldn't keep up, don't panic. Just go back and look at bits of it again.
But yeah, no, thank you for watching, everyone, and we'll see you in the next one. Cheers. Bye.
Great. Bye.